All right, so what we want to talk about next is symmetry, reflectional symmetry specifically. And that's where half of a figure is a mirror image of the other half. In the picture here, you can see the cutout of a vest, okay? And there's a line down the middle, and that line is called the line of symmetry. So reflectional symmetry is when one half is a mirror image of the other half, and the line of symmetry is the line that divides the figure into the two congruent halves. And remember that congruent means the same. Okay, there's one line of symmetry in this picture. All right, now if I take a look at these two, they would like me to draw all the lines of symmetry. Well, I know the line of symmetry has to cut it directly in half. Well, let's see. If I cut this one like this, if I folded it on that line, it would match up. So that is a line of symmetry. Now, something that kind of tricks students on this one, they think that we should be able to go like this. And at first it definitely looks like we should. But if we look closer, and let's see, maybe I'll trace it like this in black. Trace that half. Now if I take that and I flip it, and then try to match it up over here, it comes close, but it doesn't match perfectly. If you get out a ruler and measure this triangle, you'll notice that it is isosceles. Two sides are the same, but it's not equilateral. All three sides are not the same. So there's only one line of symmetry, this line I drew in green. Now, in letter B, this hexagon is a regular hexagon. Regular hexagon, regular means all sides are the same length and all angles are the same. So that's kind of a clue for you. If a polygon or a shape is regular, all the sides are the same and all the angles are the same, then the number of lines of symmetry will match up with the number of sides it has. So since this is a regular hexagon, it has 6 sides that are the same, there's going to be 6 lines of symmetry. Here's one of them. Just think, if you fold on that line, it would match up both sides. Here's another one. Now my line isn't very good. It should go from center of one side to the center of the other, and this would be a third one. And again, it should go right through the middle. So there's 3. Here's a fourth one. It goes from vertex to vertex, or corner to corner. And we can do it again here for 5, and here for 6. So kind of a clue for you, if it's a regular shape, a regular polygon, all sides are the same and all angles are the same, the number of lines of symmetry will match the number of sides on the shape. So that's why there's 6 in that hexagon. Remember, this triangle is not regular. That means all 3 sides are not the same. So there's not 3 lines of symmetry. If it was an equilateral triangle with all 3 sides the same, there'd be 3 lines of symmetry. All right. Reflection is when we flip a figure over the line of reflection. And the line of reflection is that line that we flip it over. For example, they gave us triangle ABC, and they want us to flip it over the x-axis. Well, the x-axis, remember, goes right here. To flip a shape over an axis, all you have to do is count the distance of the vertex from the line to flip it over, the line of reflection. So LOR, this is my line of reflection, the x-axis. Well, point B is 2 spaces above the line of reflection. So the copy of B, also known as B prime, is 2 spaces below. Point A is 1 space below the line of reflection, so A prime is 1 space above. Now take a look at C. Point C is on the line of reflection. I don't have to move to get to the line of reflection, which means C prime lands in the exact same place. So our image is flipped over the line of reflection. Basically, the way to think of it, the points that are above the line of reflection will be below in the copy. The points that are below in the original will be above in the copy, or in the image. Now in this one, they want us to start by making the triangle. So point A, it says, is at 3, 0. So we walk 3 and we climb 0. And that's point A. And point B, it says, is at 2, 3. Walk 2, climb 3. That's point B. And it says point C is at 5, negative 1. Point C is down here. I'm going to connect the dots, make my triangle. Looks something like that. Now it says reflect it over this line. The line is x equals 2, and if you've forgotten how to make a line like that, well, you can go back to your old xy charts. It says x is 2, y can be whatever I want it to be. So my line of reflection, it says walk 2 and climb 0. And it says walk 2 and climb 1. So my line of reflection, right here in red, L-O-R, line of reflection. Now, just like we did before, we're going to count spaces from the dot to the line of reflection. Point A is 1 space away, so A prime is 1 space away on the other side. Point C is 3 spaces away, so C prime is 1, 2, 3 spaces away on the other side. Look at point B. It's on the line of reflection. I don't have to travel anywhere. So B prime is also in that same spot. And when I connect the dots, I have the exact same triangle just on the other side of the line of reflection. They'd like us to do that again for part B, but this time we'll have a different line of reflection. So let's start with point A at 3, 0. Point A is at 3, 0. There's point A. Point B is at 2, 3. 1, 2, 1, 2, 3. Point B is at 2, 3. Point C is at 5, negative 1. Point C is here. And again, we're going to connect the dots. Here's our triangle. Now, it says y has to be negative 1. So my line of reflection this time my line of reflection is here. L-O-R, my line of reflection. And we do just what we did before. We count spaces. Point A is 1 above the line of reflection, so A prime is 1 below. Point B is 1, 2, 3, 4 above, so B prime has to be 1, 2, 3, 4 below. Point C is right on the line of reflection. I don't have to move it all, so C prime stays in that same spot. And again, we connect the dots. And it should look like the same triangle, just flipped over the line of reflection. So these are some study guide questions. You should try them. If you look at number 8 here, how many lines of symmetry are there in a square? Very key, important word there, square. Square has 4 sides the same, 4 angles all the same. It's a regular pentagon. If you think back to what we did way back here, when we talked about the hexagon, we said if it is a regular shape, all the sides, all the angles are the same, then our number of lines of symmetry have to match the number of sides. Well, I know I can draw a line from here to here. That cuts it in half, and if I fold on that red line, it should match up. And if I fold on that red line, it should match up. And if I go corner to corner. Let's see, how many lines of symmetry are there in a square? Got to answer the question. There are 4 lines of symmetry. Draw all the lines of symmetry? I did. So answer the question always. It asks you how many there are and draw them. So I drew all 4 and I said there are 4 lines of symmetry. Alright, this one's a little bigger. First we got to start by drawing the triangle RST. It says R is at negative 2, 7. So here's point R. It says point S is at negative 5, 5. And point T is way over here. And let's connect the dots. Try to use a straight line the best you can. Alright, I've got triangle RST. Now its image says is over the x-axis. So remember, the x-axis is here. This is called my line of reflection, L-O-R, my line of reflection. And again, count spaces. Point T is 2 above, so T prime has to be 2 below. Point R is 1, 2, 3, 4, 5, 6, 7 spaces above the line of reflection. So I got to go 7 below. 1, 2, 3, 4, 5, 6, 7 of them. And that's labeled R prime, remember? And S, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's S prime. We're going to connect all those dots. And it should look like the exact same triangle, just flipped over that line. Alright, last one. Same thing, they want us to draw the triangle and then reflect it over a line of reflection. So, point R is way out here at 8, 8. Point S is back here, -2, -1. Point T is at 6, -8, so way down here. Connect those dots. Got a very large triangle there. This time they say reflect it over the line x equals 1. X equals 1. Again, if you don't remember how to make a line like that, make a quick XY chart. It says x has to be 1. So, let's see, x has to be 1. X has to be 1. This is my line of reflection. LOR, line of reflection. Again, we count. So, point S, 1, 2, 3 spaces to the line. So I go 1, 2, 3 the other way, and that's S prime. Point R, way out here, 1, 2, 3, 4, 5, 6, 7 spaces. So I count 7 more. 1, 2, 3, 4, 5, 6, 7. I'm way out here for R prime. And point T, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Point T prime is way out there. And then we're going to connect the dots again. There we go. It looks like the exact same triangle, just flipped over the line of reflection. All right, good luck.